Hello there. I do believe I'm going to do some more R. What a shock. Today I'm going to do, if you haven't done these before, lapply, mapply, sapply, and what do I want to do? No. Yep. Sapply, vapply, and lapply, which can come in really handy. We'll see, for we're operating on elements of lists, vectors, and so on. These are functions. So first I'm going to create a list, but this could be a vector. Remember, if it can't find a list as input, it's going to do the best it can. So you can put matrices, you can put vectors. Matrices end up looking like atomic vectors. Let's put some values in here. See, 1, 2, 3. X2, I'll call this high. Okay, why not put complex numbers? They belong everywhere, right? Class C list, what a shock. It's going to be, guess what? Three items in there. Okay. So what does lapply do? I'll show a few tweaks of lapply, but lapply basically takes the input, whether it be atomic vector or it's a list, and it applies a function to each part of it. The function can take more than one argument. The parts of the list will be used as the first argument of the function. So we'll do a bunch of functions to see. So it's handy. If you want to, for instance, see the class of everything in a list, there's class list. I can take lapply x. By the way, since I'll talk about the infamous ... but since you can actually add lots and lots and lots of arguments, almost without count, to the lapply function, I'm usually kind of careful to make sure the x I'm putting in really is the list I want to operate on, and fun, and nothing spells fun like functions, is going to be given the explicit name fun. We'll see. X is my z list, and function I'm going to apply to it is class. Very simple, so it's just going to go down, and the output is going to be a list. Whoa, this is very deeply nested here. Okay. There we go. I can put it all in one line if I want. So we have a numeric, we have a character, and we have a complex number. Hey, we can test if they're all numeric. Are we having fun yet? Let's see. I'm actually just gonna, I don't want to save that. I just want to, I'm gonna come straight out. It's going to be a list, true, false, false. Okay. Sometimes, if you try to apply something that doesn't work, it will happily do what it can. Let's see, list. Here's a function. I'll apply dimension to each one. The trouble is, if you remember what our data structure originally contained, dimension is not going to be well defined. Remember, that's a characteristic of matrices. So let's see what happens. It's going to apply dimension to each part of it and get nulls. So okay. Let's do one that takes an additional argument. This one's, the first one's going to be kind of bizarre. Oh, no. I'll do one that's not bizarre first. I'm going to do lapply. Everything in the list is going to get the function print. Okay, so it's going to try to print each one. However, it's one at a time going to try to print each element of this list. But I want to apply another argument to print. Now, print takes an argument, certainly print.default, there's lots of prints. That's the trouble is there's going to be maybe a different print function that's going to be invoked for every single item in my list, but there's a famous one called quote, which when it prints a character string can drop the quotes. So I'll say false. And when I hit this, it's going to go through every element in the list. Notice hi is missing its quotes now. Whereas if I just use a print statement, print out. By the way, what is print out? This is a funny one. Print is one of those very, very, very annoying or weird functions where the print out, when it sees print here, just returns the very matrix, list we started with. It doesn't operate on its output for once. Print is purely a side effect. So it's the side effects of that function, printing to your screen, that appear. Most of the time we don't like our functions doing side effects. Print, that's pretty much all it does is side effects. So now let's get more bizarre. Let's look, and so I should look at print. Notice arg's print is very weird. It has the infamous ... but then again, I believe so does lapply. Yep. ... is very non-committal. It means you can add lots and lots of named arguments. In particular, with print, those control the printing. And of course, there's lots of versions of print. So depending on what you're trying to print, it could have different arguments. So quote is one of them. I'll show you how we find those. lapply takes it takes a function, and you can put additional arguments to the function in there. That's why it doesn't bother to name them, because it doesn't know how many possible arguments you could have for your function. Print. Let me peek at that print again, though. This will be a little interesting. I'm going to look at all the print functions that are out here. Turns out there's an enormous number of them. People have written print functions for all sorts of objects. Okay, so the one I really want to do to get specific, so of course it's going to give you ... because each one of these might have a different set of arguments. So to be a little more precise, I'll do print.default, which is going to be the default print, and we can look at the arguments there. Typically print, which is going to work on numerics here, you can pick a number of digits. You can say quote equals true or false. Do you print and missing data, and so on. So it has a list of arguments. So that's the type of thing I'm adding. I added to that way back when print default is invoked, I'm going to shut off the quotes. Okay. Let's do one that's a little trickier. This is a very, very, very deeply perplexing function. cbind. Remember, cbind is actually a generic also. There's a bunch of cbinds. There should be one of data frame. Okay, there is one. In fact, methods. Cbind. Yeah, there's a cbind data frame. And cbind's interesting because it has to take ... because what it does is it takes a bunch of a bunch of named data structures and tries to bind them all together into a data frame. So sometimes coercing it to a matrix, unfortunately. So let's take a look at, I wonder if cbind has a default, or if that's just the data frame. Nope, doesn't have a default, so the data frame is the default. Okay, so what happens when we apply a function like that? lapply, remember lapply, get back what we were talking about before. You take your list as input, every item of that list is going to be acted on by a function cbind. So I'm going to bind it to something. Now the rest of what I put here ends up as arguments to cbind, additional arguments. I'm going to put the argument hi. So what this is going to do, it's going to bind hi to every item in zlist. Let's take a look at what we get. I won't even check the class of that because it's a list. So notice it bound to every. It had a vector here. It bound some highs to it. Of course, it replicated them to get them to the right length. It had 3 things in this vector. It bound 3 here. Of course, this to a matrix. So you get a 3x2 matrix. You get a matrix here of highs. It attached the high to the high and attached the high to your complex. Everything got coerced to characters. So just kind of strange, but it just shows that if I put something there, anything I put here ends up being arguments placed inside that function. You can even do anonymous functions. This is a function with no name. Wow, you know, I should write a song about that. I went to the desert with a function with no name. Has a ring to it, right? Or maybe not. Okay, so where were we? Aha, function with no name. Not all languages allow you to do this, but R does. So we'll take zlist, and each item in zlist is going to get a function. I'm just going to create a function right here. I could create it and name this function outside and use it, but instead I'll just not even bother. I'm just saying function is a function. It takes as its argument x, and it's going to do something. So it will say, let's say, is numeric. Oh, let's just do something weird. Paste x with a plus after it. There we go. Having Monday effect going on here. Okay, let's see what happens. List, it's going to be what? Takes a list in, each item gets this function applied to it, and there you go, which systematically pasted a plus onto each and created a string. So on each item, each part had a plus added. So that's how you do an anonymous function. So again, I can create any function I want here, even multiple line one, and it will immediately run in each item in the list. Now, you know, if you don't have a list and have a vector, it's going to do the best it can, which is apply everything to each element of the atomic vector. So let's do a function. Here's a well-known function. It's the multiplication. And it takes 2 arguments. So this is going to be a problem because it's going to go in each of these things and say, oh, I'm going to multiply 1 by something. See, because times really is a function that takes two arguments. So I need to supply another argument. So I'll go, multiply it all by 4. Seems like a deeply stupid way to multiply a vector by 4, but hey. Notice though what it puts out is a list. So it realized what it was reading in wasn't a list, so it did the best it can and said, okay, a vector's coming in, I'll apply it to each thing in this vector, atomic vector, I'm going to multiply by 4, but it expects its output to be a list. Unless I go and coerce that thing into something simpler, I'm kind of stuck. Okay. So speaking of coercing your output, there's this nice version of the command called sapply. Let's look at the args of lapply. I think we looked at them before. This function. No. I'm always curious to peek it and see if there's versions of this. Oh, methods. If it's a generic. Nope, it's not a generic. There's only one lapply. It's not primitive. Now I just got to peek and look and say, oh, whoa, it's not, is it? Look at that. It has R code. Okay. not the world's snappiest R code. It starts with R code and then calls an internal function, but so it immediately cheats and calls code that you can't see, but hey. It is, and ooh, but this is kind of fun. Look at it. Look at the R. So lapply, when they wrote it, is a function written in R that immediately calls a function probably written in C, internal. But look what it does right here. So it's going to check if it's if not is vector. So it's going to try to, if it's not a vector, it coerces it into a list. So it expects things to be a list. However, remember when I put the vector there, it just took the vector immediately and treated one item at a time. So it's really a function that's kind of like a generic. It works both in the proper way on both lists and on vectors, but instead of writing it as a generic method, they just put if statements to try to figure out what's going on before calling the internal. Okay, enough of that. So sapply is something that does simplification. So let's do sapply. Same sort of thing. It takes in a list or a vector, applies a function to each item of it, but if it can possibly make it into a simpler data structure than it started with, it will. So let's see. So let's apply it to our favorite Z list. So what was something length? Okay, if we do length, let's look at what lapply did with length. It's just so we don't have to remember. And I certainly don't want to have to remember anything. Again, our functions, I don't have to say x equals z list and function equals length, because if you just put in it, R can specify arguments by position and expects the list to be the first thing and the function to be the second thing. I'm just keeping myself out of trouble by saying x is z list and fun is length. But the first thing's always going to, if you put in something without naming the argument, it's going to assume the list is first and the function second. So we'll put in length with lapply, and then we'll put in length with sapply. I'll even show what I said is true. I'll just put these directly in. Okay. What's the class of out? So we saw one's your list. It took each one of the items of Z list, output a list. But what sapply is going to do is say, hey Ron, what are you doing? You've got a list here with just one number in each spot of the list. I could simplify that into a vector. So let's look at what it did. Yep, it's an integer vector, in fact. So it simplified it as much as possible. There it is. So if I had said simplify is false, though, then I basically get lapply. Yep. So not much going on there, other than you can get simplification if you want that side effect. Okay. Oh, by the way, lapply works, both lapply and sapply will work for data frames. So let's get a data frame in here. Let's get the big file again. Okay. I'll do big file equals read CSV F. I actually don't have to say header equal true. I will. That's default. Okay. All right. It's a data frame. But if I want to apply something to it, it's do lapply Oh, you know, sapply would probably be snappier. Okay, so if I apply big file, it's going to go, okay, it's a data frame. That's basically a list. I'm going to apply this function to each of the columns. Okay. But the output's a list, which is kind of inconvenient, which is where sapply comes in really handy, because it's just going to look at that and say, that could be a vector. Okay, here we go. So each item, it's going to tell whether it's numeric. Good. But really, sometimes you can... how brave do I feel? I don't feel that brave right now. I want to look at vapply. Vapply is the same sort of thing, except it has a safety attached. So vapply is like sapply, but you specify the output type. And if it can easily coerce it into that output type, well, no, if the output type inherits the type it expects, then it'll run. But if it doesn't, it won't, as we'll see in a second. So what this is it can protect you by having it throw an error if it can't actually compute what you want it to compute on your list. Which, if you have a really long list, could easily happen. So let's look at our old Z list up there. We'll put a function equals length is applied to each one. Then you put fun value. And what that does, it expects a generic value. So if I put 0, or even better yet, 0L, it's just going to go, oh, integers. So it's going to say every one of these lengths had better be integers, or I'm going to throw an error. So let's see what comes out. Oop. Just like sapply, it's simplified. 311, it was fine because all of those were integers. On the other hand, well, let's see. Oop. Oh, doesn't like that. They're not characters. So funVal expected that. Values must be of type character. Instead, the function applied to these parts of the list were integers, so it throws an error. So it's just a way to protect your output. And that's about it. It's a safety type. What's one last thing? Let's do a replicate, the replicate command. So that's different from rep. You know, those R people sometimes get really annoying. So you've probably all used rep. Rep is if you put any sort of pattern, such as a vector here, you can have each item of it repeated, say, 3 times, and you get that. So it's a really easy way to get pattern vectors. Or I can go 1 through 6 and go times 3. And that'll do 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. There you go. So it's a way of getting repeats. Replicate's a little bit different. So let's look at replicate. Replicate is a way of repeating the same action multiple times and putting everything into a matrix. So let me take one peek at replicate. I want to see if it's generic or not. Replicate. Oh, is that all there is? Simplify equals array. I wonder if I can get away with not simplifying. That's making me think about something. Okay, I'm going to try something with experiment that probably won't work in a second. But so let's say I want a matrix that consists of a whole bunch of samples. So I'll do replicate. I want n equals 10 samples. So each time I'm going to take a sample from 1 to 5 of size 3 with replacement. And what this is going to do, it's going to repeat this sampling 10 times and then assemble them all into an array. Kind of neat. Wonder if I can shut off the simplification. Now I'm curious about that. That's the part I wanted to experiment on. No, no. Oh, I put it on this wrong function, that's why. That's not an argument to a sample. Okay. If you don't simplify, it's going to leave the output as a list. So it's going to make a list of each of those simulations, or in this case, samples done.